pay close attention to this problem. It will be very beneficial to you if you do. That's all I'm going to say. At a toll booth, we'll call it toll booth a sports car's receipt read 11 a.m. At toll booth B, the sports car's receipt read 11:50 a.m. So you can see it took 50 minutes to get from point A to point B. After leaving the second booth, the driver was arrested for driving over the 55-mile-per-hour speed limit somewhere along the 80-mile stretch between the two booths. Now, we need to show, we're the attorneys, right? We need to show there was a time t equals c between the booths, at which time she was speeding, and find that speed, in other words, the velocity, and make the assumption before you start that the equation of the motion is going to be differentiable on all real numbers, which they are. They are. Okay, so the deal is we are the prosecuting attorney, right? And we need to prove that this person, this woman, was actually driving over the 55-mile-per-hour speed limit in that 80-mile stretch between booth A and booth B. And we'll use the mean value theorem to do it. First of all, let's identify the equation of motion as f of t. That's the equation that describes the position of the car at any time t. Then the derivative f prime of t, you know, is the velocity. Now, we know that f was differentiable on all real numbers. That was given to us. So that implies that it's going to be continuous on all real numbers because we had a theorem, note 41, that said differentiability implies continuity. And if it's differentiable and continuous on all real numbers, it'll be so on any subset. Now, A is going to be our initial time. It starts at 0 hours. And B, our final time, which is when they clocked in at the second tower. It would be 11:50 minus 11 would give us 50 minutes. But we want this expressed in hours. Now watch very closely. 50 minutes times 1 hour over 60 minutes reduces to 5/6 of an hour. Don't forget that. You might need to make a change like that between minutes and hours. So A is 0 hours, B is 5/6 hours. Now the Y partner, the position, f of A, initial position, is going to be 0 miles because that's when we start this 80-mile trip between the two booths. F of B is the final position. That's at 80 miles because she made the entire 80-mile trip between booths. Okay? Now, as I said earlier, because I told us f was differentiable on all real numbers, that tells us it's differentiable on the open interval from A to B. Remember, we only need an open interval for differentiability on the mean value theorem and Rolle's theorem. We're using the mean value theorem here, but it's just an open interval of differentiability from 0 to 5/6 hours. And it's going to be continuous on the closed interval from A to B, 0 to 5/6 hours. You got to get those right, the open and the closed, because I will be looking closely to see that you have that listed right. Thus, the mean value theorem, in other words, note number 72, is going to assure us that there exists a time, at least one time, c, which is some value between 0 to 5/6 hours into that trip between the toll booths, such that f prime of c, in other words, the velocity, the speed at time equals c, the instantaneous speed, is equal to the quotient difference, f of b minus f of a over b minus a, which is 80 minus 0, and that's in miles, over 5/6 minus 0 in hours. Okay, dividing by 5/6 is the same as multiplying by 6/5, so we get 96 miles per hour. She is guilty as charged. Who would have ever thought an attorney needed to know her or his calculus? At least the mean value theorem.